Welcome to lecture number 8, Identity and Access Management. Typical agenda that we'll be following. First, I'll be covering the last lecture and chapter in review. Then I'll be covering what the lecture and chapter objectives are for this particular lecture. Then I will get into the lecture itself, and then I'll summarize with some review questions. So in the last chapter, we started to get into controls. Remember, we talked about the information security model where we have the assets, we have threats, we have controls and vulnerabilities and so on. So for vulnerabilities, assets, and threats, we covered that in several previous lectures, but we started to get into controls last lecture. And specifically, we talked about encryption controls, and we talked about the major types of encryption. We also presented the public key infrastructure, and we summarized other types of encryption methods that we run into on a day-to-day basis, such as RSA, hashes, certificates, and so on. So in this particular lecture, we're going to continue on with controls, and we're going to define and summarize the following: identity management, access management, authentication, single sign-on, and federation. Now, many of these are terms that you may have already come across in your day-to-day life because it's something that is basic security controls that are being implemented across the university, across multiple organizations, across different devices that you use and that type of thing. But we're going to go ahead and formalize some of those definitions for you and give you an idea on exactly how they operate so that you're able to be more literate about it when you see it in your day-to-day life. So remember, we are thinking about the information security model. In the first lecture, we talked about what information security is, what are the different aspects of it, and how we're focused on the confidentiality, integrity, and availability triad. Then we started to get into systems administration. We got a flavor of what systems administrators have to do on a day-to-day basis and what kinds of security threats they need to be aware of. What are the different types of things that they need to do in order to make sure that the systems on their organizations are running smoothly. Then we got into the information security model, which kind of merges some of those topics together, and we talked about the threats and the vulnerabilities within IT systems that information assets are stored on. And we're focusing now on controls. So controls, again, safeguards to use to minimize the threat of impacts. Vulnerabilities and threats in and against our assets are not going away, and systems administrators will typically use controls to help protect against cyber attacks, and they are the protective ring around an IT system. Some controls are very simple and they can be very effective, such as passwords, firewalls, backups, and so on. And only a small fraction of threats will actually cause a damage. And the information security's goal is to deploy the appropriate controls within an organization. And remember that there can be 3 different types of controls: physical, procedural, and technical, but not all of them are exclusive to one category. There may be a single control may fall under multiple categories. So let's get into controls. Let's keep moving forward with controls. Let's talk about identity management first. What identity management is that identifying individuals and collating all necessary data to grant or revoke privileges for these users to resources. So for example, it's username and password on a laptop. The identity is a username, and then there's a password associated with that username, and that username could be used across multiple information. And some of the challenges associated with identity management is user churn or legal requirements. And there's something called an information unit called the system of record, an SOR. These are records from which information is retrieved by the name, identifying number, symbol, or other identifying particular to the individual. So what you can think about is that this is, say, your username. If you have your username, it has a lot of other information associated with it. And this is that other information can be retrieved based off of your username. A system of record can take various forms. So it can be an ERP system at a large organization, or it could be a spreadsheet in a small organization. And each unit or function may maintain its own SOR. So for example, there could be SORs for students, employees, and so on. And an identity is a distinct record that's stored within an SOR. It's a more formal term for a computer user. Identities are identified by an identifier. So it's a string of digits which uniquely identifies an identity in an SOR. And the same individual may have multiple identities across an organization. And it's useful to reconcile and get a complete picture of somebody's activities within the organization. And this is done through the identity management process. So a system of record could have multiple identities underneath it, and a single person could have multiple identities across an organization. So for identity management, the way that you can go ahead and use that, you can think about it in 3 stages. First, there's identity discovery, where we have a system of record, and then within that system of record, we are trying to identify or discover the identity. Then we're going to do identity reconciliation, so we're going to identify all of the different identities that are actually the same, that they can be reconciled. And then there's also the third one, which is identity enrichment. So if we wanted to go ahead and increase the amount of information associated with that particular identity, we can. And then all of that is stored into a person registry. So identity discovery, getting a little bit more in depth into it, is locating all new and updated identities throughout the organization. So you want to search all of the SORs for additions, name changes, role updates, corrections to date of birth, corrections to identifiers, and so on. In large organizations, there could be multiple automated systems. There could be thousands of pieces of data and dozens of systems scanned several times per day. So you need some sort of an automated approach in order to do identity discovery. Whereas in small organizations, this can be done manually at recruitment or time of termination. Identity reconciliation is comparing each discovered identity to a master record of all individuals in the organization. So for example, a professor taking a course, perhaps starting a new research project, two separate identities are reconciled. So for example, we have Henry Jones right here. His birth date was the 13th of March 2020, and his department is archaeology. And then here we have Henry Jones again with the same birth date, but he's in a class of biology 101. So what we can see is that there is the identifier of the employee and then also of the student. And you can go ahead and reconcile that accordingly. So instead of having 2 records, you could have 1 record where there's an identifier, the first name, last name, and then you have the student ID and employee ID associated with Henry Jones. A person registry is a central hub that connects identifiers from all systems of records into a single master identity. So it makes the correlation and translation of identity data possible. And so the identification by user and not by identity, it may issue its own identifier. So we saw in the previous example that there's an own identifier that's associated with Henry Jones. Social security numbers can offer this function, but the reason why they're not used is because in case the system gets breached, it will limit the amount of information leakage that comes out from it. Identity reconciliation, which is that last stage, includes 3 main functions, which is identity matching, identity merging, and identity creation. So matching means that you want to match the same person as the person registry, given that set of identity data. Merging it is you go ahead and combine the new and updated record with the data associated with an existing person record. So what we can see here is Henry Jones. We combine the information for Henry Jones accordingly. And then identity creation is creating a new person record and identifier in the person registry. And this is also called a match and merge in the industry. And you can see that this is a breakdown of how you could think about it. So does this identifier exist in the person registry? If it does the name and birth date match the identity in the person registry? If not, update the name. If so, do the other attributes match this identity in the person registry? And if it's no, update the attributes. And you can see the same decision path down here. Identity enrichment is collecting data about each individual's relationship to the organization. Example shows adding affiliation. So you're adding in information for Henry Jones accordingly. So the reason why we do what we talked about here is because within an organization, there are different people within that organization. It's up to the systems administrator to make sure that they know all of the different identities that are in that particular organization. What you'll find is that a lot of systems administrators will want to know what the identities of the people are within their organization. They want to reconcile them accordingly, and they want to manage it accordingly. And the reason for that is because some of those old identities, if they're not reconciled appropriately, They could actually be used by hackers in malicious forms. They could be used in social engineering attacks. They could be used to steal data from the old accounts and that type of thing. So that's where identity management becomes so important. In terms of the role, a role is an individual's relationship to the organization. So individuals can often have multiple roles. So there could be faculty members, students, administrators, parents, and so on. And you can define what's called a primary role for a particular person who may have multiple identities that are reconciled together and so on. A primary role is a role that has the greatest impact in determining information privileges. So it assigns priority values to each role. And a role with the highest priority value is the primary role. So identity management completion, identity enrichment completes the identity management. All of the information necessary to assign information privileges has been compiled into the person registry. So at this point we know all the people within our organization. And what we can do with this information is that we can provide it as input to an access management system. So now we've got ahead managed all of the identities within our organization. We've reconciled them accordingly and that type of thing. And that could actually be used as input into what's called an access manager. And that access manager will help you identify who gets access to what within an organization. So let's get into that right now. Access management. So all policies, procedures, and applications which make decisions on granting access to resources. So for example, you want to use the data from the person registry and the systems of record. The key thing is that you want to make sure that there is what are the common principles associated with access management. So for example, role-based access control, granting individuals in specified job roles access to privileges associated with the corresponding system role. So making sure that you understand what everybody's system role is within an organization and granting them the appropriate access privileges. You don't want to give root access to everybody within an organization because that's not going to be beneficial. They're going to start to be able to download and install pieces of software which you may not want to have installed. And then also separation of duties. More than one person is required to complete a task. An access registry is a single view of an individual's accounts and permissions across the entire organization. So you have already resolved all the identities within an organization. Now what you want to do is that you want to assign the appropriate access control to each of those individuals. And the access registry will give you insight into who are the different people within the organization, and then what types of access that do they have to what. So you can also run periodic access audits, determine the access each individual should have. So this is based off of the data in the person registry as well as current security policies. And the access registry, it's comparison of access registry data and access audit results. So you want to determine what access should be added or removed. Just because you had access to something in the past doesn't mean that you should have access to it now. And the reason why this becomes important is because when you have things like PCI compliance, payment card industry compliance, you have to meet certain types of access that your employees can have to certain parts of the network, just to make sure that all of the payment card information is stored appropriately and disseminated appropriately. So in the access registry, it can help you out significantly in trying to identify who gets access to what. So you want to send provisioning actions to each affected service or system, so creating accounts, adding permissions, deleting accounts, revoking permissions, and that type of thing. And you all have knowledge of this based off of your hands-on activities and past assignments. So authentication. Authentication is the process the user goes to prove that he or she is the owner of the identity being used. So it's most commonly done by using credentials, and all of us have used a username and password credential in our lives. So there are different types of credentials that are out there. In general, the types of credentials that exist are something that you know. So a password is something that you know. It's a string of characters that help form a sequence that you input into a form or input into a computer that will allow you to get access into something. So that's something that you know. And if you share that information, that's something that everybody will know. Something that you have is something that you personally own, that belongs to you specifically. So you can think about this as a private key within the encryption within the encryption lecture. So we have the private key. That's something that you have. And then something that you are is like biometrics. So it's like your thumbprint or your retinal scan and that type of thing. Ideally, the strongest authentication will have all three aspects. There's something you know, something you have, and something you are. But most of the time, what we're dealing with is something that you know. Now, if we take into account, say, something like the iPhone, right? What it is that it's taking into account something that you are, because it has a thumbprint reader on it. And many other phones have this type of capability as well. So passwords is something that you know. It's a secret series of characters that's only known to the owner of the identity, and it's usable to authenticate identity. There's many different advantages associated with it. So for example, it's easily understood. There's no end user training. It's free, so it's very startup friendly. It's very effective, assuming that people will make sure to have the usernames and passwords. Now, a little bit of a tangent here about passwords. I personally think that passwords are one of the mechanisms that vendors can do to ensure security within an organization. What I mean by that is that if you remember the SCADA case study that was involved in the previous assignment, what you saw with some of the vulnerabilities was that it had default username and password credential vulnerabilities. So that means that that particular device which was scanned actually had default username and passwords that it still accepted. Now, the issue with this is that if you know the default username and password, somebody can easily go into a user manual and identify that accordingly. Now, what I personally think is that the vendor should actually have a piece of software in there or command in there that upon startup, the user who has started up the device or the SCADA system must change their username and password upon first login. That will significantly improve the security of those SCADA systems. Moreover, what the command could be is that you have to fill in the username and password, and the password has to be of a certain complexity. So that's just a little tangent. It's a little bit of a viewpoint that I have, that cybersecurity is something that could actually be commanded on by the vendors themselves. Now, getting back to passwords themselves, the main limitation with passwords is that they can be broken. And in terms of password breaking, this is something that's very useful to know if you're trying to protect systems. There's two different ways of password breaking. One is what's called a brute force attack, which is trying all possible character combinations until the password is guessed or every possible combination has been tried. So up to 6 character passwords can be brute forced in minutes, but then after that it starts to get a little bit more, lengthy in time. Dictionary attacks is trying to guess thousands of passwords from massive dictionaries of common passwords and words from multiple languages. So stolen passwords from insecure sites greatly simplified tasks. And I'll also put this out there. I know that many of you, not that I've ever talked to you about this guy, but I know that many of you are probably using the same username and password across multiple sites. And this is just so you don't have to remember multiple usernames and passwords. Now, the issue with this is that if there's a major breach that happens, what happens is that the username and password that you're using could get dumped to a publicly sharing website called like Pastebin or something. And then hackers will actually take those publicly available usernames and passwords and try them on other major sites. And say that 5 million usernames and passwords have been taken from a major site. Let's just say Twitter, for example. And then they try those 5 million usernames and passwords. They set up a script that will try those 5 million usernames and passwords on Facebook. Even if 2 million of them work, that is still a significant amount. That's 40% of the passwords that they took from that were breached from Twitter, and they're using it on other sites. That's a very significant amount, and they had to do very little work. They didn't have to do any type of brute force attack or anything like that. They just got to see whether or not your username and password was the same across multiple sites. So that would be, say, something like a dictionary attack. So password recommendations, they're usually derived from user psychology. People have cognitive limitations. Hacker motivations, passwords may be broken. Threat models, the leaked passwords. So for example, the 2009 breach of online game service RockU, more than 14 million usernames, passwords, and plain text, and that type of thing. So password recommendations is the threat models. What the hackers will do is actually use heuristics to guess passwords from known passwords. So you can follow this link, but they will actually use a script like this. So they will look at look at what the characters are within each of the passwords, and then start to guess accordingly. So some recommendations is that you want to minimize the number of accounts that you're having. It reduces the chances of harvesting. More importantly, at least 8 characters to prevent brute force attacks, and maximize entropy, making sure that everything is changed up throughout the entire password. So combine lowercase, uppercase, numeric, and special characters in a non-predictable manner. So this prevents exploitation of harvested passwords. So use phrases. So I love COB, College of Business, USF Bulls. It's easy to remember, but potentially more secure. And separation of concerns. Keep financial passwords separate from other passwords. Tokens, getting back to something that you know, something that you have, something that you are. Tokens are something that you have. They're physical objects that are presented to prove a user's identity. In the case of software tokens, they're stored on a physical object. In practical use, almost always combined with a password. So it's something called two-factor authentication. So a simple example, we've all done this, is an ATM. A debit card is a token, and the PIN is the password. Tokens, they're not entirely secure. But it's not very easy to break them. So in this example, an engineer was sent a token and password to a company in China. It paid a fifth of a salary to do his job. And it was considered to be a very productive employee. So some token types that are out there, say, are like store IDs, digital certificates, dedicated readers. They're hardware tokens, so these generate numbers based on a predefined sequence every 30 seconds and so on, and entered in a conventional form. There's no new hardware needed. And I remember my mom actually used to use these types of tokens where she would actually use one of these hardware tokens that will generate a passcode every 30 minutes or so, and she would use that passcode as input or as a password into a site. Now there are software-based tokens. So smartphone applications that generate number sequences, so no new hardware needs to be carried or issued. There's also text messaging based tokens that when using a new machine to log in, the service sends a number to a pre-registered cell phone. Now biometrics, this is one of the cool ones. It's something that you are. It's analyzing the minute differences in certain physical traits or behaviors, such as fingerprints or the pattern of blood vessels in the eye to identify an individual. Changing technology and its impact, so DNA fingerprinting, reasonable biometric identification, or unjustified search and seizure. So how do you actually go about using this accordingly? Some biometric markers, there is observable physical differences among people. So required properties of biometrics is that it must be universal. Everybody should have that trait. The uniqueness, no two people should have the same trait. The permanence is that no trait should change over time. Collectability, the trait should be measurable quantitatively. Performance, the accurate measurement should be inexpensive. Acceptability, the user should allow measurement of the trait. And circumvention, difficulty of imitating traits of another person. If it hits all of these characteristics, then what's going to happen is that it's going to be a good biometric marker. Fingerprinting is one of the more common forms of biometric markers, but the issue with that is that the permanence. You could actually burn off fingerprints. If you think about like Men in Black, the first one, they burnt off his Will Smith's fingerprints, so he no longer has fingerprints. Well, that actually could be done in real life as well. So the popular biometric scanners, like I said, they're fingerprints, and you can see that you can actually break it down. You can actually quantitatively break down the distances between the ridges and that type of thing. There's also iris scanning. It's fast, but it's less accurate. And there's also retinal scanning as well. So biometric theft. So what happens if a biometric is stolen? So passwords can be reset, but you can't reset a fingerprint. You can do what's called cancelable biometrics. Use encryption controls such as hash functions and so on. Save a hash of the biometric and never the actual biometric itself. And if it's stolen, then rehash the biometric. So you're not actually scanning the biometric. What you're doing is actually inputting a hash. And one thing I want to point out is with all of these security controls, you may use one of them independently, but oftentimes what you'll find is that the strongest controls are when you combine them together. So let's get into single sign-on. So we've already talked about identity management. Identity management, we want to go ahead and reconcile all of the identities within an organization such that you can lead into access management. Who gets access to what? What privileges do people have? What privileges do people have to access certain programs, execute certain tasks, do certain things within a network, and so on. Authentication is that how do you authenticate people to get access to what they're allowed to get access to? Single sign-on is a form of password management. So at school, you can think about the learning management system, library system, parking transportation system, registration system, tuition payment system, and so on. If you open up new tabs and try to get access to all of them, you're going to be signing in over and over and over again. So it's very tedious to re-enter the credentials. Single sign-on allows a user to authenticate once and then access all authorized resources. It's popular in large organizations. So take USF for example. There's My USF. You can go ahead and log in through My USF. You have access to all of the different USF aspects. You can get access to your paycheck. You can get access to your courses. You can get access to parking and transportation services, and so on. The implementation is that the system maintains separate passwords to each system, and the user signs into the SSO system, and the SSO system provides passwords on the user's behalf. And the benefits of this is that it increases user experience significantly. There's more secrecy and potentially stronger security. The problems with it is that the compromise has a bigger impact. If you get that initial set of username and password, the NetID from My USF, then the compromise is significantly bigger because then you're able to get a larger scope of what you can get access to. There's greater complexity and it's a single point of failure. So password synchronization is that ensuring that user has the same username and password in all systems. The password changes on one system are propagated to all systems. However, the user enters password in each system separately. There's no central repository. So for example, across Windows and Unix and across Windows and Google apps. Now what Kerberos will do, which is a different form of password management or single sign-on, is an authentication protocol that allows nodes in an insecure network to securely identify themselves to each other using tokens. And it's the basis for many single sign-on implementations. And it was originally developed in the 80s by MIT and it was publicly released in 1993. And it's used as a base for many various commercial technologies such as Active Directory, which we talked about Active Directory in previous lectures, about how systems administrators will actually use Active Directory as a mechanism for access management, where they're able to identify all the users within their organization, group them up based off of role, and assign them privileges accordingly, or assign privileges to certain individuals accordingly without them being part of a group. So Kerberos, the essential configuration is that an administrator adds a client system to the realm, and it's the basis for confidence in identity. The key distribution server in the realm authenticates client access and grants resource access. So these are tickets. These tickets are presented to the service. So for example, the printer, the service trusts the tickets, and without verification with the KDC, you'll get access to what you need. And you can see a diagram right here. So you'll get a ticket request, the ticket that's sent back, the service ticket request, and the service ticket that's sent back. And then you present the ticket to the Kerberos server, and the Kerberos server will actually open the channel for you. So the advantages for Kerberos is that it's a high degree of confidence in identity. It's initiated by corporate systems administrators, and it's publicly available technology. It's like TCP and IP. It's inexpensive, and it's robust. The disadvantages is that it's not usable on the web. There's no shared realm that's available. How can you be confident of identity presented by Amazon's web server? Or how can Amazon be confident about your laptop's identity? So there are limitations associated with Kerberos. With these particular limitations, there are other forms of web authentication. There are two forms. There's what's called token-based and federation-based. Token based is that the client server trusts a central token provider. So it's like Kerberos key distribution service, but not each other. So federation based would be user specified mappings between accounts on different services. So Central Authentication Service, CAS, was developed at Yale in 2001. It's popular in many educational institutions, and you've all used it as part of MyUSF. It's similar to Kerberos in use of ticket. So what we've got here is that we've got the web request from the web browser to the application server. We've got a redirect to the CAS server. Then the web browser will actually have to input the username and password credentials to the CAS server. Then once it's done, the CAS server will store the TGT in a session cookie on the web browser here. So we're getting into some of the networking stuff that you may cover in previous classes, but don't worry too much about these little details here. There's a web request that's sent to the application server, it's validated, and then the username and attributes are sent back to the server as well. So that's just an overview of how Kerberos type things are implemented in web authentication. So it's making sure that there is authentication across multiple services such that the end user can get access to what they need without having to sign in repeatedly on those multiple services. Let's talk about federation. Federation-based web authentication is bridging the gap between authentication systems in separate organizations. So there could be researchers at a startup firm, and this firm is affiliated with a university. A 101 solution would be 2 separate accounts for each researcher at startup. The problem with this is that it's unnecessary sharing of confidential information between the university and firm for account creation. And what if the researcher is fired from the firm? How does the university know how to revoke access? There's going to be a lot of redundancy. There could be a lot of significant threats just from insiders based off of that. So one solution is what's called federation solution. It's only one account. It's at the primary location. So for example, the startup. Other locations can trust identity verification provided by the primary location, called by the identity provider. In our example, when a user from a startup requests access to a university resource, the university system will direct the user to the startup for authentication. And the university system trusts the authentication provided by the startup. So whatever the startup is saying about that particular user, the university will trust that accordingly. So SAML is used to exchange authentication information. So it's what's called a security assertion markup language, and it's similar to token exchange. SAML-based federation can be maybe seen as a flexible CAS. So organizations can choose CAS providers. And so you can see how it's broken down right here. The first step would be to request the access. The second one would be redirecting. And then the third one would be the authentication request to the identity provider, just to make sure that the identity is who they say they are. And then the request credentials come back to the browser. From there, there's a user login to the identity provider. And then there is a signed SAML response. And that is passed to the service provider right here. And once that happens, the protected resource gets provided to that particular person. So it's essentially what's happening is that the browser is asking for resources to the service, but the service will check first with the identity to make sure that the person says who they say they are, and more importantly, they're allowed to get access to that particular resource. And the identity provider will provide information back to the service provider so that the service provider can provide whatever is being requested. So you can think about it almost like a background check. The person that you're getting a job from, the employer that's providing you that's maybe doing a background check on you, will check on your past employers. You can think about them as the identity provider. They are the people that will be able to speak on your behalf that, hey, this person is legit, this person is able to, doesn't have a criminal history and that type of thing. Discovery service, should every institution trust every identity provider? This is something that's very important for an organization to discuss up front. And one of the mechanisms that you can consider is what's called a discovery service. It provides users with a list of trusted organizations that they can choose from to authenticate. So there's something called OpenID. It's a further generalization of federation. A user can select an ID provider. There's no special configuration at the relying party's end, and it does not receive SAML response from client. It directly receives authentication confirmation from the ID provider. We've all seen this. Sign in using your account with XYZ, Facebook, Foursquare, Google, Yahoo, and so on. Authorization is what if you want to be able to access certain specific resources from a secure site. There's something called Authorization. It's a mechanism that allows a user to grant access to private resources on one site, the site provider, to another site, the consumer. And one common example is what's called OAuth. The mobile application can access information from a secure site. So what we covered in today's lecture, we talked a lot about identity management. We talked a lot about the different types of roles and separation of duties. We talked about access control. Who do we want to get access to what and that type of thing. We talked about credentials. What are the different types of credentials? Something that you know, something that you are, something that you have, and so on. We talked about the different ways that passwords can get breached. We talked about the different factors for biometric markers, single sign-on, authentication, federation, and all these types of things. Now, what I want to emphasize on is that these are all tasks that are conducted by a systems administrator, but it's very important for the systems administrator to be very clear on the business processes that an organization has, such that he or she knows exactly the appropriate controls to put into place that would A, make sure that the business processes within an organization are being followed, and more importantly, that there's effective cybersecurity posture within a particular organization. So as always, feel free to reach out to me if you have any questions. Thanks.